Hello there! How have you been? I hope you're doing great in the comfort of your home as you continuously enhance your mathematical skills. Be ready with your paper and pen as we venture on a new lesson in general mathematics. Are you ready? Let's begin. At the end of the session, you are expected to differentiate horizontal and vertical asymptotes and determine the horizontal and vertical asymptotes of rational functions. The main highlights of this session is the topic about asymptote. What do you mean by that? An asymptote is a line that a curve approaches or gets closer and closer to but never touches. It could be a horizontal, a vertical, or a slanted line. Let's begin understanding vertical asymptote. By definition, the vertical line x is equal to a is a vertical asymptote of a function f if the graph of f either increases or decreases without a bound as the x values approach a from the right or left. To clarify on this, let's look at this graph of a rational function. Observe that the curve from left or right approaches an imaginary line right here, which will be represented by this blue broken line. And that is what we call as our vertical asymptote. Let's zoom in to have a closer look. Here, the curve approaches from left or right to this value of x. That is, x is equal to 1. And that is our vertical asymptote. I repeat, our vertical asymptote here is x is equal to 1. That is being represented by the blue broken line in this figure. Now, how do we find this value, which is x is equal to 1, as our vertical asymptote if we are only given a rational function? To find out how, let's see some examples. Given f of x is equal to x squared minus 5x plus 6 over x squared minus 4, let's find the vertical asymptote of this rational function. You may pause this video and give it a try. I know you can do it. Go ahead. Now, to find the vertical asymptote, let's follow these steps as your guide. Step 1, let's reduce the given rational function to lowest terms. And that is with the help of the second step. Let's factor the polynomial in the numerator and denominator if both or any is factorable. So let's check the numerator and the denominator if it can be factored. It can be factored into this form. Now, how did we come up with that? So let's focus first on the numerator. So let's take that out. We have x squared minus 5x plus 6. This trinomial can be factored. So how? So let's review on this. Let's look at the last term, which is positive 6. And let's jot down all the factors of positive 6 into this table form, where we see the first and second column for factors, and the last column will be the sum of the factors. So what are the factors of positive 6? We have here positive 2 and positive 3. When you multiply the two numbers, it will lead us to a positive 6. What else? We also have negative 2 and negative 3. Another factor is we have positive 6 and positive 1. And we also have negative 6 and negative 1. Now, after getting all the possible factors of our last term, which is positive 6, let's get the sum of the factors. So we have 2 and 3. The sum is positive 5. Negative 2 plus negative 3 will give us a negative 5. 6 and 1 will lead us to an answer of 7. And negative 6 and negative 1 will give us a negative 7. Next is, let's find the factors whose sum will be equivalent to the numerical coefficients of the middle term. And that is negative 5, since the middle term is negative 5x. And that will be the factors negative 2 and negative 3. Hence, our factors are x minus 2 multiplied to the quantity of x minus 3. That's how we come up with these factors in the numerator. Do you understand? Okay, so I hope that is a yes. So let me continue with the denominator. So our denominator here is x squared minus 4. The first term has an exponent of positive 2, which is an even number. That indicates that the first term is a perfect square. So if a variable has an even exponent, that makes it a perfect square. The second term here is a positive 4, which is also a perfect square. Let's recall this table. We have here numbers 1 to 10, and in the second column, the squares of those numbers from 1 to 10. Here, 4 is the square of 2. That makes 4 a perfect square. Since both are perfect squares and are separated by subtraction, so this qualifies to a special product which we call as the difference of two squares. So the factors of this special product, difference of two squares, would look like this, wherein the first terms are the roots of the first term of our given, which is x squared. So that will be x and x. And the second terms of our factors are the roots of our second term, which is 4. That's why we have 2 and 2. And the factors are now the sum and the difference of the root. We have x plus 2 and x minus 2. So those are the factors of our denominator. So let's proceed to step 3. Step 3 is we will cancel out common factor or factors. So here, they share a common factor, and that is x minus 2. Correct. So we'll cancel that one out, and let's proceed to step 4. Step 4 is we are going to rewrite the reduced rational function. Since we already canceled out x minus 2, it will give us, after that, our next step will be we are going to find the values of x that will make the denominator equal to 0. So our denominator here is x plus 2. So let's take that out and equate that to 0 like this. Let's subtract both sides by 2 to cancel out 2 to find the value of x, like this. So we are left with x is equal to negative 2 as our vertical asymptote. Again, our answer here is x is equal to negative 2, and that will be our vertical asymptote. If we are going to graph the given rational function, it would look like this. And our vertical asymptote is at x is equal to negative 2, which is represented by the blue broken line as shown. So here, it means that the graph approaches but never touches x is equal to negative 2. If you're going to look beyond and zoom in, you'll see this. There. Zooming it further, you'll have this. As you can see, this is our vertical asymptote, and our graph, or the curve of our graph, approaches but still never touches this vertical asymptote. Are we clear with that? How about in the lower part of our graph? Let's look into that right here. And let's zoom in this part of the graph. And we will see this. Similar to earlier, the curve of the graph approaches but never touches our vertical asymptote, which is x is equal to negative 2. Are we good? Okay, so let's proceed. Let's practice more. How about this? Given f of x is equal to x minus 4 over x minus 5, find the vertical asymptote of the rational function. You can pause this video and take your time. Go ahead. Okay, so these are the steps that we followed in example number 1. So let's take out the given. F of x is equal to x minus 4 over x minus 5. Step 1, reduce the lowest term. That's a check since it's already in its lowest term. No other common factors in the numerator and in the denominator. Step 2, factor the polynomial if factorable. Since the given is already in its lowest term, that means step 2 is also a check. How about step 3? Cancel common factor or factors. No other common factor or factors that are present in this given since it's already in its lowest term. So that means step 3 is also a check. Step 4, rewrite the reduced rational function. I repeat, this is already in its lowest term, so that means it's a check. Step 5, find values of x that will make the denominator equal to 0. That means we will skip steps 1 to 4 and proceed directly to step 5. Again, step 5 is we will find values of x that will make the denominator equal to 0. So let's take the denominator out and equate that to 0, like this. To solve for x, we will now add 5 to both sides of our equation. So that means x is equal to positive 5. And that is now our vertical asymptote. X is equal to 5. Looking at the graph of this rational function, this is the vertical asymptote of this rational function. We have x is equal to 5 represented by the blue broken line in this figure. We are done with vertical asymptote, so let's hop in to the next or to the other asymptote, which is the horizontal asymptote. It's defined as, here, the horizontal line y is equal to b is a horizontal asymptote of a function f if f of x gets closer to b as x increases or decreases without bound as x approaches to positive infinity or x approaches to negative infinity. To understand it further, let's look at the graph of this given rational function. Observe that the curve approaches but never touches an imaginary horizontal line represented by this blue broken line. This is the horizontal asymptote, and that is expressed as y is equal to 1 since the horizontal line is at point 1. In determining the horizontal asymptote of a rational function, this would be our guide. And this is a very important guide, so you should remember this. Here we have 3 conditions. We have n is less than m, n is equal to m, and n is greater than m. So what do you mean by n and m? N and m, n here is the degree of the numerator. It's the highest degree of the numerator of the given rational function. And m is the representation of the highest degree of the denominator. If n is less than m, the horizontal asymptote is y is equal to 0. So that's it. If the given rational function has n, which is less than m, then automatically our horizontal asymptote is y is equal to 0. The second condition, if n is equal to m, the horizontal asymptote will be in this form. Y is equal to a over b, where a here is the leading coefficient of the numerator and b is the leading coefficient of the denominator. Since the degree in the numerator and denominator are equal, you will be using this to get your horizontal asymptote. The last condition is if n is greater than m. To find the horizontal asymptote, let's open that one. There, if n is greater than m, then there's no horizontal asymptote. So these are the 3 very important conditions that you need to keep in mind as you find the value or as you find horizontal asymptotes of rational functions. So let's have an example to fully understand this part. Given f of x is equal to x squared minus 5x plus 6 over x squared minus 4, let's find the horizontal asymptote of the rational function. You may pause this video and give it a try. I know you can do it. Go ahead. To find the horizontal asymptote of this given rational function, let's follow these steps as your guide. Let's identify the degree of the numerator and the denominator. It's represented by n and m. So here, this would be the highest degree, x squared in the numerator, and x squared also in the denominator. So the value of n is equal to 2. Same with our denominator. Since it's x squared right here, our m is also 2. Do you follow? And let's recall our 3 conditions earlier. So this example would fall into the second condition since n is equal to m. To find the horizontal asymptote, that is, we will be looking for a and b because y is equal to the quotient of a and b. That would be our horizontal asymptote. Now a here is the leading coefficient of the numerator. So a here would be this, the leading coefficient of x squared. So that will be 1. And b is the leading coefficient of our denominator. So we have x squared again here, and the leading coefficient for that would be 1, similar to our a. So we have a and b, which is equal to 1. Right there. So let's use y is equal to a over b and substitute the values of a and b. Since a and b are both 1, so that's 1 over 1, which will lead us to an answer of y is equal to 1. And that is our horizontal asymptote. Yes, y is equal to 1 is our horizontal asymptote. Looking at the graph of this rational function, we'll see this. So this is the horizontal asymptote at y equals 1. Okay, so that would be for example number 1. Let's have the second example for you to work on and for you to find the horizontal asymptote of this rational function. That would be this one. Find the horizontal asymptote of this rational function. F of x is equal to x squared plus 1 over x cubed minus 4x plus 3. Go ahead and pause the video. Alright, similar to example number 1, let's find the degree of the numerator and the denominator. That is expressed as n and m. Highlighted are the highest degrees in the numerator and in the denominator. So in the numerator, that is x squared, and in the denominator, that is x cubed. So our n here is the exponent of x squared, that's 2. And our m is the exponent of its highest degree, that's 3 for x cubed. So again, n is 2, m would be 3. After that, we are going to recall the 3 important conditions. Since n is equal to 2 and m is equal to 3, that means n is less than m. So among the 3 conditions, that will be the first condition, wherein again, n is less than m. Since in the first condition, we already have here the horizontal asymptote, which is y is equal to 0. Automatically, our answer is this. Y is equal to 0. That's it. Now, this is the graph of our rational function. There you go. And as you can see, this is the horizontal asymptote at y is equal to 0. Do you understand? I hope your answer there is big yes. Well, if not, no worries. Again, you can always go back to the portion of this video showing you the step-by-step solution in getting the vertical and horizontal asymptotes. So that ends our second example. Now this time, it's activity time. I prepared here a 10-item assessment for you to work on and to check your understanding for this lesson. We have here in this table 3 columns where you can see the first column, the given functions, the given rational functions, and in the second column, you have here, you're going to find either vertical or horizontal asymptotes. And on the third column, you're going to write your answers. So you may pause this video or take a screenshot of this activity and answer this one during your free or available time. Go ahead, you can pause the video. And that concludes our lesson about vertical and horizontal asymptotes. Congratulations, students, for always doing your best. Keep it up and see you in the next lesson.